Hello, my name is Suhas. This is an assignment regarding Skyfi Labs project. Uh, in this video, I'm going to show you how to design a foundation for a high-story building. First, we need to make sure that the size of the column, dimensions of the column should be known before designing a foundation. For that, open your assignment which is done before, click on study 1, click on columns, double click on column. Here we can see dimensions of a column as 500 by 500, like that. First make sure that you have written the noted the dimensions of column, and now know the materials which are used in the construction of this building. Here you can see that concrete M40 is used for construction of this building. Mile HYSD 500 rebar is used. Note these two materials. Now open Safe software. This is the foundation for the tall building which is shown before. For the building, we are using raft foundation. Can be called this foundation can be also called as mat foundation. First, from the software, we need to define all the materials. Here you can see that HYSD 500 and M40 grade concrete are already defined. From the ETAP software, about the building structural designs, we got information that there are total 16 columns of different sizes, which are the dimensions are respectively as 500. Each column dimensions as 500 by 500 and 600 by 600, and safe bearing capacity of soil should be 300 kN per meter square, and the column dimension should be 4 meters. First define all the properties, like slab properties. Here the slab property is already selected as 1220 mm. It is already analysis is done. Cancel. Okay. Draw the slab using draw slabs and areas option, and draw design strips with this option. And now assign the load data. These are already assigned. If you want to clear information about the data, click on right click on the point object, and we can see that 2969.65 and force gravity is dead load is acting, and live load of 1425.6 kN per meter square is acting. We cannot select all the columns at a time and assign loads. Why? Because the dimensions of the columns are different and the loads are also different. That's why we need to select each and every column for the assigning of loads to the respective of columns. Okay, now we're going to run after defining assign all the loads. Subgrade option also. Soil subgrade property data. Here the subgrade modulus should be 3 into 10 power 4 kN per meter cube. Note it as a 3+04. Click on OK. This is also defined. After defining all the materials and drawing all the slabs, columns, design straps, then assign the loads to the respective columns, slabs, and strips. And now analysis. You can see the deformation of all the slab footing area, like it is already defined as -2. Deformation ongoing below the footing area, that's why it is showing minus values. And now if you want to display any loads, strip forces, click on moment, apply, toggle all the options for the maximum moment data. If you want shear force, play on it. If you want to shear force on both, it can be shown like this. axial force. There is no axial force. Torsion. These are all the forces with respect to numbers. And now display, if you want to show slab forces, click on Vmax for maximum shear data. This is the maximum shear data. We can select on any different places. This also given the graph is value is 111.45 into 10 power 3, as it is exponential to power 3. Now analysis and design. After analysis and design, we need to know how punching shear stress. You can see all the punching shear stress at different columns are less than 1, so that we can say that the columns are safe, the footing is safe. If not, we need to change the thickness of slab for punching, for the limited value of punching stress, and run detailing. Click all the options selected. Now these are all the click on detailing option, and now click on plus data and add general source and add drawing components. Click on slabs and views, double click on frame plan. Now it is showing frame plan of the raft foundation. And now rebars table is individual rebars table of bar marker and diameter which are needed, and the rebars schedule. These are the different types of different rebars, such as the build quantities. It will show the bar sizes and the length and weight. The total weight is 23.15 million-newtons. And now individual slabs. This is a rebar plan of the raft footing. Top rebar plan. This is bottom. We can select different types of hull bars. We can see through this detailing option. Section 1. Section 2 is the top view. Reinforcement area. These are the details about the reinforcement which is given in the layer A. This is layer B. And if you want to see the 3D view of raft foundation for this building, click on XY, click on 3D. If you want to see the 3D view of all the building, extrude, click on extrude, click on OK. This is the total 3D view of a raft foundation with 16 columns. And if you want to see the finally, you can come to conclusion that with the help of these tables, the concrete slab flexures and shear data, click on OK. Different shear data at different columns. If you see the status check as OK, you can come to conclusion that the building is safe, the foundation we have designed is safe to use. Thank you.